Good morning. Today we are going to look at how we can put functions together. That's called composition of functions. You already know some ways to put functions together. You've been doing this. So for our example, we are going to use f of x equals 3x minus 1 and g of x equals x squared plus 3. So these are our two functions that we're going to be working with today, and you know some ways of putting these together. And I should say this. So I know you're used to seeing functions called f of x. But if we named every function in the whole world f of x, you'd be like, oh, hold on, which f of x are you talking about? It'd be like in a family. What if I named all my kids the same name? That would be terrible because you wouldn't know which kid I was talking about. So we just give them different names. No big deal. So that's it. Alright, so let's see. If I have these two functions, here's what you already know how to do with them. We could add these functions together. So that's old news. You could take the 3x minus 1, that's the f of x, and add x squared plus 3 to it. So I'm adding those two functions together. I could do a little combining of like terms and call it x squared plus 3x plus 2. That would be fine. To subtract them, you've done this before, so I'm going to take the f of x and I'm going to subtract the g of x. Now the g of x is going to go in parentheses because that subtraction is going to apply to all of it. So you would do subtraction is the same as, adding the opposite. You could like distribute that negative sign. So that's old news. You've done that before. Multiplying, that's old news because you could take the binomial, the f of x part, the 3x minus 1, and multiply it by this other binomial, x squared plus 3. Multiply those together, double distribution property. You've done that before. And then dividing is the most recent one you've done. That's where you would do long division and put the x squared plus 3 inside. I would have to put a plus 0x because we're missing a term there, and put the 3x minus 1 outside and do long division. Okay, so that's all old news. You know how to do those things already, okay? We are going to talk about a new way of putting functions together, and it's going to be called composition of functions. And the idea of it is that you're going to use the product, the output from one function as the input in the next function. It's going to be like a chain of events. So I have that started here in your notes on this next slide. Okay, so give me a second. Okay, so I have visual aids to go with this today. So what we have is we are going to have our two functions be like two factories, okay? And what this factory produces, so factories take raw materials and then export them as a finished product, okay? So this factory, we are going to say that it takes ore from the earth, like metal ore, and melts it down. It's a refinery, and it produces pure metals that are able to be used, okay? So that's what this factory does. And then this factory takes the metal that this factory is putting out and uses it as its input, and we'll say it makes cars, okay? So that's what's going to happen. So we get a raw material coming in here, goes into the first factory function, all kinds of stuff happens, you get a product that comes out, and then that gets shipped over and becomes the input of our next function. Chain of events is what you see happening here, okay? So let's see what that is going to look like with some numbers. So let me remind you that f of x is 3x minus 1, and g of x is x squared plus 3. Okay, so let's say we are going to use an input of, how about 2? So 2 is, let's see, let me show you here. 2 is our input, and it's going to go into f of x. So what does this function do when it gets a 2? Well, it's going to take that 2 and multiply it by 3, and then subtract 1. So 3 times 2 is 6. Subtract 1, we'd be at 5, okay? So the output that comes out here is, ta-da, look at that, It's a 5. Woohoo! So now that is going to become the input for our g of x function. So 5 is going to go into this function. So 5 goes in. Now what does g of x do? It takes its inputs, squares them, and adds 3. So what that means is we're going to take that 5 and square it, so we'd be at 25, and then add 3 to that, so we'd be at 28. So 5 goes in and into the g of x factory, and 28 comes out. So, oh, I don't know if you can see that. Ta-da! 28. So that is the idea of how composite functions work. Okay, so now let's look at that within some math symbolism. Okay, let's see what this will look like in math symbolism. So what we have done is we took f of x, we put something into f of x, got that answer out, and put it into g of x. Okay, so there are two ways that you can show this. One is you can say g of, oh, that looks bad. That is supposed to be a little empty circle. Let's try that again. G of, eesh. Third time's the charm here. There we go. F of x. Or you can write it like this. Or g of f of x. Okay, both of these forms of symbolism mean the same thing. So the little open circle, I don't even know what it's called, it does not mean multiplying. Okay, I think this is a kind of bad choice for them to choose for this symbol because it makes you think of a dot for multiplying. It's not what we're going for here. We're going for the f of x is going inside of the g of x. So I kind of like the second symbolism better because you can see that the f of x is here inside the g's parentheses. Okay, so that kind of makes more sense in my mind. And the reason that you can tell when you look at that the f of x is what's going first is, remember when you had sets of parentheses in the order of operations, and sometimes you would have round parentheses and the square bracket kind, and remember how you started on the inside ones? Same thing is happening here, okay? So since f of x is on the inside, we're evaluating that part first, okay? So those are the two symbolisms that you will see for this. So let's go through what we just did with our factories on paper or screen here. So what we found was we found g of f of, oh no, what did I put in? I think I put in a 3? No, a 2. Okay, 2 was my original input. So a 2 went in for f of x. So starting on the inside part, we figured that out. Okay, so I put the 2 in for the x. It was my input, and I got an output of 5. So like off to the side, I could say that I'm finding f of 2, that it equals 3 times 2 minus 1, and that equals 5. So f of 2 equals 5. So if you remember, that was the output that came out of our first factory, our first function, okay? And that is what then went into our second function, g of x. So now I'm going to find g of 5, because f of 2, the output from the f function, when I put a 2 in, was a 5. That's what came out. So that's what the function of 2 is. So now I need to find out what I get when I plug the 5 in. So then 5 went into the function, the g of x function now. So if I'm going to find g of 5, let's do this off to the side. G of 5 means that I'm going to take 5 and square it and add 3. And if you remember, we said 5 squared is 25, add 3 to that, and we got 28. Okay, so our final answer here is 28 when we put those together. So now I wonder if the order matters. Do you think it matters if I put something in f of x first or g of x first? Like, does it make a difference? Like, sometimes it does with things like subtraction. It makes a difference what order you put things in, but adding it doesn't. So let's just experiment with this and see what happens. So now I want to find f of g of x. F of g of x. And I'm going to put that same input in again. So remember, that was our input. So we're going to find f of g of 2. So now the 2, let me switch these around here. The 2 is going to go into my g of x function first, okay? So now this one happens first. So 2 goes in. So that 2 is going to get squared, okay? So 2 squared, that would be 4. And then we're going to add 3 to that. So we'd be at 7, okay? So a 2 went in, and 7 comes out. So I'll write that down on the screen in a minute. Now 7 is going to go into our f of x function. So 7 was the output here, but it's the input in the next, since this is like a sequence of events. So 7 goes in here. 3 times 7, you'd be at 21. And then subtract 1, you'd be at 20. Okay, so let's see. I can document that. F of, let's find g of 2 off to the side here. So when I put the 2 into the g function, which was x squared plus 3, I will get 2 squared plus 3, which is 7. So that 7 is going to go into my f function. So the output of the first one becomes the input of the next. So 7 goes in here. So when I do f of 7, I get 3 times 7. And then I have to subtract 1, so that comes out to 20. So my final answer is 20. So was that the same answer or a different answer that we got before? Well, before we got a 28, so the order matters on these. Okay, so let's make a note of that. The order matters in which you perform the function operations does matter. So inside goes first. Inside function goes first. So same idea that you saw when you had parentheses, the round kind and the square brackety kind, you did the inside one first. So that makes sense. Oh, okay, so now you probably noticed that I used the nested parentheses notation more than the other kind, because I don't really like the other kind. So when I see the other kind, I personally immediately just switch it to the parentheses kind. So this becomes g of f of x. Okay? And then I go with it like that. If the little circle thing doesn't bother you and you would know to do the f part first there, go for it. Okay? That's fine. Now, one other thing I should say is you can't always do a chain of events. Okay? So let's say that we had a different 2 set of factories here. So we'll say we have f of x, and then this one is a new one. Okay, this is h of x, now new factory. Okay. Oh, I think I reversed this. It doesn't matter which box to switch. Okay. So let's say I'm gonna put in a I don't know. How about -2? Okay, we're gonna put a -2 into this function here. -2 goes in. That's my input. So I take the -2 and I multiply it by 3, so I would be at -6. And then I subtract 1, so I'd be at -7. Okay, so the output is a -7. So -7 comes out. So if I'm doing a composition of these functions, that output, that -7, is going to become the input to my next function. So this function is h of x, and it equals the square root of x. So it takes its inputs and it square roots them. So I'm going to take this -7, and I'm going to put it in here. And this factory is going to reject this. I'm going to spit it back out there. Because, can you square root a negative number? Is that something that we do with real numbers? No! So it would be kind of like in life if this factory, let's see, I think the first one before I said was refining like metals, like iron ore and such. So this factory is a refinery, refines all kinds of metals, and one of the things it refines is gold. And this other one was a car factory, and so this factory produces gold, pure gold, and it tries to sell it to this factory, and this factory's like, no, I'm a car factory, I don't want gold. He's like, but I made it. And he's like, no, I don't need that. That's not an input that I need. So you can't always put functions together like that. Sometimes you have a limited domain. So you'll explore that a little bit more in pre-calculus. But yes, that is the idea of composition of functions, where you put them together. The input goes through one function, produces an output, and that output becomes the input of the next. So that's everything you need to know, I think. So remember that Jesus loves you, and so do I, so do your math.